I'll just jump right in. Thank you, Trent, actually, for having me here and giving the opportunity to present with you guys. Obviously, my goal today is to go through kind of the basic of drone surveying, at least as we see it. So everything I'm going over is going to be a fairly high-level overview of a lot of the capabilities, where it stands today. And then I know we'll have a bunch of time for Q&A at the end as well, because there are a lot of questions. I may not get to everything just because, I mean, drone surveying is a massive industry. I give talks that are sometimes 4, 6, 8 hours long and just on this stuff, and there's still more to talk about. And I'm really passionate about this industry. I like it. I think it's an awesome technology. And yeah, I'm happy to show you guys everything that we're doing with it, and where you guys could be going with it as well. So yeah, the main objective is just an intro to drone surveying and a Q&A about drone surveying and some of the types of works that we do. This is in no way at all a sales pitch or anything. This is truly like how we view the process of drone surveying. But just a little bit about us. We have been doing drone data processing for land surveyors since 2014. That is all we do. We work exclusively with licensed surveyors and engineers. So we actually have gotten over the last 6 years to know this stuff pretty darn well. A little bit about me. I am the CEO, founder, and lead photogrammetrist of Aerotas. With my background, I actually have an educational background in finance and statistics. And statistics is what led me into photogrammetry. And I am a certified photogrammetrist as well. So that is my kind of credentials on that end. And one of the things that you'll actually hear me that I bring up right at the beginning is that our philosophy to drone surveying is that if your drone program isn't saving you time and money, it isn't working. We very much have a philosophy here that drone surveying is not a science fair experiment. This is not, ooh, cool, let's see if we can buy all of this money and do something cool with it. We're very laser focused on how to use it in business, right? If you spend $100,000 on a drone, on hardware, and it takes you 50 hours in the office or something to actually get a single half-acre project site done, that's bad. That's a science fair project. We don't like it. So I'm going to reference that a lot. And it's one thing that's worth noting, because a lot of times people say, ooh, what about this, things on the cutting edge? Is it possible? Because a lot of times the answer is, yeah, it's possible, but it doesn't make sense to. You guys are surveyors. If it makes more sense to use a total station, use a total station. I'm not going to say, yes, you can, but you'd need to take 8 million photos from these angles, and you'd need a server the size of NASA or something to process it all. That's not where we go. We really do focus on very practical applications on this, and how you can use this technology most simply, most effectively, most reliably, things like that. So to start with, one of the things that I often talk about is what the drone surveying journey looks like for most people. A lot of times, most of you have probably seen drones before, whether it's just a kid's toy or you see something at the park. And the place where most people start is just taking photos and videos. The technology has gotten so ridiculously cheap, reliable, and accessible that you can go out and buy a drone. I mean, heck, even one for a couple $100. They'll fly up a couple 100 feet and take really high quality photos and videos of a job site. And that's where most people start. And then they start adding more technology and getting more and more competency. They start throwing it through some software to get ortho photos, ortho-rectified imagery, so kind of a basic imagery map of a site. Then they start working in their ground control points, their RTK data, PPK data to get higher accuracy, higher precision, where you can actually start making reasonably good measurements out of it. Then you start working in your 3D data, your contours, your elevations, your break lines, that sort of thing through your digital surface models and point clouds. You start getting it into CAD, Civil 3D, Carlson, making a final survey deliverable. And then at the very end of this is what we call an integrated workflow. It's where you actually take that workflow and make it something that is repeatable, is easy to use, is understandable, that you can use on every single project. And that's really the goal of all of this, is again, not to create that one-off science fair project where it's cool, but then you or your crews don't ever pull it out of the truck because it doesn't save them money. You want to make it integrated as part of your workflow so that it makes everyone's life easier, from the field crew to the office guys to your end clients will wind up liking this stuff and saying, hey, wow, that looks so much better with the imagery. You turned it around faster, it's cheaper, makes you more competitive on bids. That integrated workflow is really how you wind up getting all of that last stuff put together. And to do that, there are a couple of really important steps. So these are the main 5 steps that I will go through that goes from the, I'm thinking about using a drone on a project site to final deliverable. Starts with mission planning, which is of course the basic where to fly, how high to fly, what should you use a drone at all, data collection going out in the field. And then the office components are photogrammetry, which is image stitching, drafting your line work, extracting the data that you want, and then finishing it in CAD, putting everything back together in CAD for a final deliverable. And I've got some examples of this stuff too. Because ultimately, what you're looking for, or at least what clients and users are looking for, is a survey. Very, very, very few people look for a drone survey. They want a survey, and they don't care how you get it. Some clients do, of course, and it is important to disclose methodology, obviously, but ultimately, most clients don't dictate, you must use exactly a Trimble R10 or a Leica GS16. They say, get me a survey and make sure it's accurate. And so this is what a final deliverable looks like. A good chunk of this was collected with a drone, but not all of it, because some of it includes, there's easement data and other data on there that can't be seen from the air. But this is what a final survey deliverable should look like, part of that integrated workflow with drone and your other data sources as well. But to start off with, one of the things that I like to talk about first that everyone's interested in is the latest in drone technology. First off, the main thing about drones is actually not the drone itself, it's the sensor. That's what gets you your data. And there are 3 major categories. The first is a drone-specific camera. If anyone has a DJI Phantom series, Phantom 4 Pro, Mavic series, Phantom RTK, that's what you're getting. These things are built into the system. They're extremely reliable, super, super easy to use, and actually get really good accuracy. Far, far, far and away, that is the most common thing in drone surveying. The 2 on the right are considerably more expensive options where you get specialty independent cameras that you build onto a custom payload. We don't like those because they're not because the data's bad, but because they're really, really expensive and complicated and error prone. And then LiDAR is the most recent one that's really interesting. In fact, some of you may have seen either an email for us or an announcement from DJI. DJI actually recently announced a new LiDAR payload for one of their drones. And it's not cheap, but it's way cheaper than existing LiDAR options. Currently, a good LiDAR option costs about $150,000. The new DJI one, all in, so the sensor, the drone, like literally all the stuff you need, you're looking at about $45,000. So still not cheap at all, but considerably better. Hasn't been released yet. That's coming out probably in January is when they'll actually start shipping. So we will be some of the first to, we already got our orders in with DJI to get those early so that we can do the early testing on it. So we'll let you know about those and our test results the instant that we get them, if it actually lives up to the hype. Overall, LiDAR actually is a really incredible technology. It's not super common. Drone LiDAR, I should say, is not super common yet, just because it costs so much money to do it right. $150,000 on hardware plus a very well-trained operator to be able to manage it, manage data, process the data. It just winds up being ridiculously expensive. Also, as I say here, it doesn't live up to all the hype. It's not like you can fly a LiDAR rig and do perfect topo on 400 acres of extremely dense vegetated canopied forest land. Not quite that simple. But like I said, the main thing is the cost, and that should be coming down in the very, very near future. We're super optimistic about that as far as LiDAR goes. But those are kind of the main sensor options. Right now, like I said, the ones that are built into the small multi-rotors, like the Phantom 4 Pro, the Phantom 4 RTK, are way, 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 like by far the most popular drones. They're the best jack of all trades. For anyone that's not familiar with drone surveying, that's the place to start. You can start in with the Phantom 4 Pro at just a couple $1,000s and get very high quality data. And then if you do have specialized applications like large multi-rotors are often used in really restrictive areas where a regular drone maybe can't fly low enough. Fixed wings are used for really big ones. I'm talking multiple hundreds of acres of site for a fixed wing to make sense. Those small multi-rotors are really the jack of all trades. That's what we recommend. Right now, the best drone out there is the DJI Phantom 4 RTK. It's the best all-around drone. It's about 12 grand all in for the drone, the batteries, and all of the other stuff that you need with it. And that's probably the best all-around one right now. But we also we are starting the process of updating our best drone in land surveying sub post that we update every now and then for this quarter. So if you want, you can always go to our website and sign up for our emails and stuff and see that when it comes out to learn more about the different airframes. So that's hardware. But now to get back into what the actual process of drone surveying looks like, as far as those kind of 5 steps that I had. The first one is, of course, mission planning. And mission planning is really, really important. But first, we have to talk about what it is. It's asking basic sites like, is this a good site for drone photogrammetry? Not every site is. Like I kind of mentioned, vegetation is a big problem. If you have dense tree canopy and you need ground topo data, drone photogrammetry is not going to be the best solution for you. As well as asking a few other questions. Is it legal to fly here? What altitude should I fly? What's the appropriate overlap? How many ground control points should I set? Where do I set them? And how do I arrange the flight pattern? And then what still needs to be ground surveyed? For people that have actually done a couple drone surveys in a row, they know this is actually really easy. You get to know this pretty well. It's not rocket science whatsoever to figure out these questions, but it does just save you time to ask it in advance to decide whether or not you're going to use a drone or whether or not you're going to bring out the GPS or the total station or any other number of tools available for you guys. We talk about what's a good project for drone photogrammetry. General rule of thumb, good projects for drone photogrammetry, anywhere between ½ an acre up to about 500 acres. Anything smaller, it is typically faster and more cost efficient to just shoot everything on the ground. Anything larger, it starts to make more sense to hire a traditional manned aerial photogrammetrist. Same thing applies with linear projects. If you're doing any sort of corridor mapping, railroads, pipelines, things like that, up to about 20 miles makes sense to do via drone. Low to moderate vegetation, getting topo mapping, ALTA surveys, planimetrics, volumetric calculations, all really, really good. That's really where the drone shines at saving a ton of time and money in terms of getting drone surveying data. Bad projects are, like I said, very large projects, dense vegetation. If you're standing under trees and can't see the sky, then the drone can't see the ground. I also put on here extremely high accuracy tolerances. I know there are certain things like wheelchair ramps under ADA rules that really need to be shot with a total station to get the accuracy down to a few hundredths in some cases. But right now, really the cutting edge drone photogrammetry will get you a little bit better than 1/10 of a foot, but not a lot better. So if you reliably need better than 1/10, maybe you have to use a total station. Likewise, indoor, underneath overhangs, and underneath trees are all kind of the things that you learn are not your ideal projects, but obviously that good projects list has a pretty wide number of things in there. As we talk about more mission planning with overlap and accuracy, one thing that I always say is you got to start with your desired result. Actually, I'm going to take 2 seconds back and pause and say, please feel free to interrupt me. If anyone wants to turn off their microphone and just interrupt with questions, I do like answering questions. It's oftentimes more fun than just speaking at my computer and hoping you guys can hear me, that my microphone didn't get unplugged or something. So please feel free to chime in if you do have any questions.
Hey, Logan, Robbie Dillon. You're sounding great. Appreciate you being here today.
Thank you. Appreciate it, Rob. So with mission planning, what I like to say is start with your desired results. One of the things that we see a lot, particularly among people that are getting started with a drone program, is just, yeah, we'll fly the drone and let's see what we can get out of it. And I like to say that's basically the same as saying, let's send a crew out to a job site with some tools and see what they get. They might get something, but you can pretty much guarantee it is not going to be anywhere near what you actually need. So you need to start with knowing what data you want to get. Are you getting topo data? Are you getting imagery? Are you tracking site progress? Are you trying to calculate the volumes of stockpiles? Because the drone can do a lot. And if you don't actually answer this question up front, then you're probably not going to get anything useful out of it. As part of starting with your requirements is know what accuracy you need. Are you doing just rough 1-foot topo over a very large project site? Or do you need really tight tolerances on a smaller property? Generally speaking, the higher you fly, You cover a lot more area, a lot more ground with a slightly lower accuracy. But generally speaking, most projects that we see are flown at about 200, 250 feet elevation, and 100 foot is reserved for very tight, small projects that are mostly hardscape. 400 feet is when you need rough topo over very large, large areas. In fact, I do actually have some examples here. Zoom thing. There we go. Like this is a huge, you know, I think I want to say this is 50, 80 acres or something, just big dirt grading lot, empty lots that was done via drone that just needed rough contours. So it was flown at a couple hundred feet, and this is what our final product looks like. And you'll notice this isn't a, you know, fancy point cloud or something. This is actually clean topo so that it's not contours driven like going all around the tractors and trailers and everything. This is really what a final drone product ought to look like. And of course, these are just our CAD standards, but you know, making it look right to you is dependent on your project needs. So that's kind of what it looks like and where your requirements are for the actual accuracy. Other things that commonly get asked are things about overlap with a drone, front lap versus side lap. What are the different requirements? There's a lot of, I want to say, debate almost within the community of what the right overlap is. Traditional aerial photogrammetry uses very low overlap because they're using extremely expensive cameras. We have found through the many thousands of projects that we've done, the sweet spot is about 75% front lap and 75% side lap, which means that each photo overlaps about 75% of the photo will be covered in the next photo. That gives good reliability and redundancy and high accuracy without getting too much data. And too much data, as I'll talk about in a second, is very much a problem with photogrammetry and with drone surveying. Another question we often hear is nadir versus oblique. Nadir photos are ones that are pointing straight down. Oblique photos, as you can see here, are ones that are at a slight angle. Our research, and we have done a ton of it, has shown pretty unambiguously, you want to take almost exclusively nadir straight down photos. Obliques can offer better identification of vertical features, but at the cost of more processing time and lower resolution. In fact, as you see here, with those images on the right, when you're looking straight down vertically, those squares are pretty big, but with high obliques, those squares get very, very, very small off in the distance. And that means that you actually get much lower resolution, lower image quality when you start including a lot of oblique photos in your job, in your project. So nadir only straight down is our recommendation the vast, vast, vast majority of times. So best practices with mission planning: single lawnmower flight path, something like you'd see on the right, all autopilot based, 75-75 overlap, and nadir only with no obliques. Though, as I mentioned, part of the reason we have those recommendations is because there is such a thing as too much data. It really frustrates me that in the world today, everyone says data's good, gather more data, gather more data. But the problem is data is expensive. It's expensive to gather all of that data because you're paying your people time in the field. And if they spend 4 times as long in the field, that costs 4 times as much money. It's expensive to store, it's expensive to transfer, it's expensive to process. It takes a lot of time. You need much more powerful computer processing. So in general, wherever possible, it actually does make sense to fly higher, fly a single flight path, and not go crazy with overlap overkill. Because again, if you start doing that, you go back into that realm of science fair project that I've been talking about. It might get you cool data, but it's so much of a pain, so awful that no one wants to deal with it. So yes, there is such a thing as too much data. Next up, I'll briefly cover ground control point planning. Ground control points are the aerial targets that are actually going to take those photos and anchor them down to your project site. They're really, 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 really important for land surveying. In fact, they are necessary for anything that qualifies as land surveying. Without ground control, it can be off by as much as a couple of feet, and oftentimes it'll put the whole project angle or something if you're doing topo. So ground control points are necessary to bring projects into your exact coordinate system, whether you're using NAD 83 or a local coordinate system or anything like that. it anchors the project to your coordinate system and makes sure that everything is accurate down to that 10th of a foot that we've talked about. Rule of thumb for smaller projects, 5 targets, 1 in each corner, 1 in the middle. That works up to, maybe 100 photos is a good way to do it. And obviously make sure that they're not obscured from the air or anything. The number of ground control points that you need really depends on your accuracy spec though. The higher you fly, the less control you need. So if you're flying at 400 feet, those 5 ground control points will actually cover about 50 acres. If you're flying a lot lower at 100 feet, those 5 ground control points may only cover 5 acres. So this kind of goes back to those infield trade-offs that when you're covering a lot of land, you really want to fly higher because you can set less ground control as well, saving more time. Whereas you need that higher accuracy, yep, you spend a little bit more time setting targets, but that'll get you that higher accuracy. Larger the project, more ground control you need. Pretty straightforward, kind of goes without saying here, just some examples. And of course, I will have a copy of this deck available to everyone after the fact if you want to look through any of this stuff. With the advancement of airborne RTK and PPK data, that's something that we're seeing a heck of a lot more now, which is great. The technology for airborne RTK and PPK has advanced dramatically and is really high quality now. However, do not believe the hype that most hardware companies say when they're like, you don't need ground control points whatsoever. It's got RTK, it's perfect. That is just not true for surveyors. Surveyors have a higher tolerance for accuracy. The RTK data is very, very good at determining where the drone was when it took the camera. But you do not care about where the drone was, you care about where the ground is. And in between the drone and the ground is the camera, and there's a lot of noise there. So you actually do still need some ground control just to make sure that everything is in alignment. As far as camera calibration goes, you can see shifts of up to half a foot, sometimes more, even with perfect RTK, PPK data. So if you take one thing away from this slide here at least, it's that do not trust the people that say that RTK means that you don't need control. As surveyors, you need control, 100%, at least to get survey grade accuracy. If you just want a pretty picture, then sure, go for it. Next up, let's talk about field data collection. This one we can go through really quick and it's easy because quite frankly, field data collection with the drone is push a button and the autopilot flies itself. The main things about data collection are knowing which data the drone can't collect. So you shoot your targets in the drone beforehand, and then you collect your data the drone can't. Things like boundaries, especially buried monuments, of course. If you're doing an ALTA survey, there are a number of things that legally have to be shot on the ground. Monuments, your ADA compliant areas, and anything that's obscured from the air, but the drone is capable of getting pretty much the rest that you need. As far as actually collecting your data, we recommend checklists. We give these things out for free that are just little things to keep you on track, keep everyone together, keep you from making the really stupid mistakes that I used to make all the time, like leaving batteries in the office or not remembering a memory card, because then when you get to the office and you don't have those, or when you get to the field and you don't have everything you need, it's a real bummer. And maybe that's why you have 170,000 miles on that on your truck in a year and a half, is because people have to keep going back and forth to the office because they forget things. But hopefully not. Maybe it will at least prevent 1 or 2 return trips to the office from just forgetting something stupid. But yeah, the field operations workflow is pretty straightforward. You check your site restrictions, check the weather to make sure it's not raining, pack everything up, and load the mission and click go. Like, these drones literally, truly, completely fly themselves. There is no piloting, no skills, no crazy stuff necessary. Erase drone pilot in order to fly a survey. So that's the field half, but what a lot of you are probably interested in is the office side of things. The field workflow, like I said, has gotten complicated. So the office workflow is these final 3 steps of photogrammetry, drafting line work, and then CAD finishing, right? Photogrammetry really gets you those first couple of steps on that drone survey journey. Linework drafting extracts valuable data, and it's kind of bringing it all together in CAD that gets that final portion. So the first step is photogrammetry. Now, what is photogrammetry? Photogrammetry is the art and science of taking 2D photos and turning them into 3D accurate data. There are lots of softwares out there, from Pix4D to Drone Deploy to Agisoft, Metashape. We're familiar with all of them. They all actually work for different applications. But generally speaking, the photogrammetry step takes your photos and ground control point data and turns it into a point cloud, an ortho photo, and a digital surface model. Then you need to take that digital surface model and reduce it into something that's useful. For anyone that's dealt with point cloud data, whether it's from a drone or from LiDAR, you know that it can easily go 10 gigabytes in size and break even the most powerful office workstation. And you certainly can't just give a 10 gigabyte to most of your clients that actually want an ALTA survey, for example. So what the Linework Drafting stage does is it takes those rich outputs and it extracts the actual data. It's putting the different layers on things, drawing curb lines, creating a clean topo tin surface that is actually usable, getting rid of things like vegetation, vehicles, artifacts, interpolating your lines underneath trees, all the stuff that photogrammetrists have honestly been doing for a very, very long time with traditional photogrammetry. This is not reinventing the wheel compared to traditional photogrammetry at all. It's just kind of applying the newest technologies to it. And then you bring it all together in CAD. You merge your field shots in, create a clean surface, add your annotations, make sure that it prints out at the right scale that you need, that sort of thing. And that is then how you get to your final survey deliverable. So just to kind of summarize what the office workflow steps look like, you start with photos, ground control points, and RTK or PPK data. That goes through the photogrammetry step, which gets you an orthophoto, digital surface model, and point cloud. Then that starts to go through the Linework Drafting stage, which will get you your 3D points, your polylines, typically in like a DXF format. You get it in CAD finishing, merge everything else together, and that actually gets you your final project in a DWG AutoCAD package, something along those lines. So let's go into detail a little bit of that, a little bit more, starting with photogrammetry. Photogrammetry actually gets the biggest amount of, I guess, hype and airtime almost, because there's so many softwares out there, Pix4D being the primary one. Photogrammetry is the art and science of making measurements from photographs. So like I said, take those photos, integrate everything together to get that 3D model. But it has problems. If you look here, this is what a raw output from photogrammetry often looks like. And you can see that it has drawn contours around the cars. There's some artifacts on those vehicles. And they're pretty noisy lines, not to mention that the files are absolutely huge. But the biggest thing to be aware of is that photogrammetry actually takes a lot of time. It takes a little bit of human time. If you have a skilled photogrammetrist, they can knock out most projects in a couple of hours, but it takes a lot of computer time. There's a lot of data, and this is why I talked earlier about there is such a thing as too much data. Even with a high-end, $5,000 computer, a big project will take overnight to process. And if you made a mistake at all, it might take overnight to process again, and it can take a very, very long time. So that's important to be aware of that. And the reason why a skilled photogrammetrist really matters is so that you get it right the first time and don't have to take weeks and weeks and weeks fiddling with data to get high-quality results. But there are different structural options for it. You can do automated-based, cloud-based processing. That's like a company like Drone Deploy. Drone Deploy is fantastic. They are fully automated, very affordable. You drag and drop photos and you get a pretty picture. Super, super fast, super cheap, but generally very low accuracy. It usually will not have the accuracy tolerances that surveyors require. The other common one for surveyors is local processing software, which is going to be buying a copy of Pix4D or renting it for their monthly fee or everything. Gives you a ton of control, but it's very expensive. It's a long learning curve, and you do need to have your own hardware and everything. So that's an expensive commitment. Or, of course, there are firms like us that do outsourced photogrammetry. We do photogrammetry and CAD drafting for our clients and all of that. So it's flexible, no learning curve, but of course we charge money. So that's kind of the downsides there. So it's a lot of really just picking what type of thing you need. If you need really fast, not very accurate though, go for the automated processing. It gets you high quality imagery much faster and cheaper than anything else. If it's got to be right, then hire someone like us. And if you have a ton of free time on your hands and a lot of budget, then maybe do it yourself. But there are options for how to get photogrammetry. Ultimately, we are powered by Pix4D. For us, that's the market leader in photogrammetry software. It's a great software, but the good software does not make photogrammetry perfect. It's not about having the right software in the right settings. It's about the workflow. It's about training. It's about looking at the software and making sure you get high quality data. In the same way that buying a license to Civil 3D does not make you a surveyor, you have to know how to use Civil 3D. Buying a license to Pix4D does not make you a photogrammetrist. It's just a tool that you need to be trained and understand how to use, but it is a very powerful tool. And if you do want to learn more about photogrammetry, there's a nonprofit called the ASPRS, the American Society for Photogrammetry and Remote Sensing. They've been around since the 30s, so forever doing traditional photogrammetry. I am certified by them as well. They offer tons of educational resources and certification for learning a lot more about photogrammetry. ASPRS.org, great organization. We really support what they do in terms of actually training and teaching people to become better photogrammetrists. All right, so that's the photogrammetry step. A lot of hard work, only to get you this big, cumbersome, messy, useless point cloud. So next step is the Linework Drafting, which is extracting valuable data off of all of that. And like I said, it's the process of reducing a rich model down to a CAD-friendly surface. Photogrammetry outputs are typically too big for CAD, and you need to reduce it all into CAD-friendly compatibility and actually get your right layers, get what you need. You need to know the number of parking spots in a office complex. A point cloud is not going to give you that answer. So like I said, there are a couple of reasons why it's necessary. The files are too big, too much data you don't, and not enough data that you do need. It's ugly. There are bad contours. There are artifacts that you might see in certain things that all need to be cleaned out. Like I said, the automated contours are not something that any surveyor would ever want to deliver to their client. They look very ugly. But like photogrammetry, there are different ways to do line work drafting. There's some automated software out there right now that you send them a point cloud and it tries to automatically extract data. We have had, I'm being honest, pretty bad experiences with those so far. They're very inaccurate and require a huge amount of quality assurance work in order to get high quality data. You can draft it yourself. That's the most known way to do it. Reliable known product to have your own people just draft, extract data. But the problem is it's expensive because you have to pay for all of it. It's very time consuming. Or again, hire a photogrammetrist. This is what photogrammetrists have been doing for decades, just with different technology. It's now done with the drone. People always ask, what's the best software to use for this? There is no single magic software. We use a lot here, just some of the softwares that we use to actually extract data, sometimes from the point cloud, sometimes from the orthophoto, sometimes from the digital surface model. And at the end, like I said, Linework Drafting also takes a lot of time, like photogrammetry. But Linework Drafting takes very little of human computer time and a lot of human time, like a lot of human time. It's very, very tedious. It takes good QA/QC to make sure that you don't miss things. And there really are no magic solutions out there for how do you start with photos and then actually get a good CAD file. We have all kinds of CAD draft standards as well. Just make sure that you understand how things are marked, right? If you look on here, how do you mark the topo around vegetation? How do you deal with drawing curb lines when there's cracked concrete? What different curb lines do you mark? How do you interpolate lines that are going under trees? Having those CAD standards is very important for creating a reliable, high accuracy product. And again, what we've done is we have not reinvented the wheel here. We've relied on the learnings from traditional aerial photogrammetrists over the last 70 years or so to guide what our CAD drafting standards look like. So if you've ever received files from an aerial photogrammetrist, our data is going to look really, really, really ridiculously similar because we've kind of been cut from the same cloth there. And then the CAD finishing part is really important to make it into that last step to actually being usable. Getting that site culture, getting those annotations, saying which streets are where and how many parking stripes and that. Merge everything together, your drone data with your field data, which has already been talked about. Create your actual tin surface in CAD, get your major contours, your minor contours, your annotations, your scaling, You get your custom layer templates to make sure that it's exactly what you guys need, that it matches your project. Improve your visibility by assigning symbology to different trees and signposts and manhole covers and yada, yada, yada. And then the last part that we do actually is adding in CAD friendly imagery. This is a surprisingly tricky part that we have really perfected over the years of actually getting imagery that is usable, but not enormous. Because full resolution ortho photos are often many, many gigabytes. And if you try and load them into Civil 3D, they just explode, which is a pain. So having good compression algorithms that optimize everything for context and printing and backing all of your line work up is really, really important in getting that final survey delivered. Because once again, this is what the final product should look like. It should look like a survey, something that you've seen before, and it should look the same whether it's been made conventionally or with the drone. The drone is just more likely to have better, higher quality, more up-to-date imagery, but just as accurate as before, and usually better, faster, and cheaper. That's really the dream of this technology. It's here. It's really cool. So just to wrap things up, and then I will open things completely to QA. Like I said before, our focus is saving time and money. A lot of technologies way out there on the cutting edge that can do cool things that you might need $1 million budget for. And actually, if you want to talk about those, I'm very familiar with them, but we just don't recommend them to our clients because people don't have a $500,000 budget for whatever the shiniest new toy out there is. Another thing that in summary, that I want to hammer home is to make sure that you pick the right tool for the job. The drone should be a tool in every surveyor's truck, but it should be just that, a tool. A drone does not make someone a surveyor, and it saves a bunch of time and money, but it's not the jack of all trades. It will not replace your GPS. It will not replace your total station. Like, it is a great tool to have, and make sure that you pick the right tool for whatever project you're working on. Also, make sure you use a complete workflow. You get any one of these steps, if you just kind of blow it off, can wind up just costing you time. It doesn't make it impossible, but it winds up just taking a lot more time if you don't get things right. One of the stories that I always like to finish on is we've seen a lot of situations of what I call good gear, bad workflow. This is an actual example of a client we had that wound up spending nearly $100,000 on the highest end equipment you've ever seen. It was a micro drones drone, a $20,000 Intel Xeon server, licenses to Pix4D and Topodot and Trimble Business Center, and massive upfront costs, like I said, almost 100 grand, and they took 50 to 60 man hours per project, and the entire program wound up being canceled because it was so expensive and so time consuming that they did not use it on actual projects. We saw the data, we processed the data for them. It was spectacular quality data. That's not the issue. It's that it was just way too expensive to have the right workflow. Or good workflow example is using something like a Phantom, cheaper drone. You fly the site, shoot your GCPs on one day. Next day, you upload it to us. We process the photogrammetry, the Linework drafting, and we deliver all of that stuff to you. And the third day, you can verify the data in the office, merge in your field data, and deliver it to a client. That's a good workflow. That's how a lot of people wind up making money on that. Much smaller upfront cost. If you're using the basic Phantoms, you're looking at a couple $1,000s total all-in cost to own the equipment, and only 10 or so man hours per project. So saves time, saves money. And ultimately, that's what we do. We do our line work products. We do topo surveys. We do full line work. We do ALTA surveys. If you want to check out more, you can go to aerotas.com. You can check out our demo projects, or you can shoot me an email. I know Trent is recording this as well, so we'll get you a copy of the slide deck and the video so you can see it. But with that, I will happily open the floor up to Q&A and questions that anyone might have for the last 15 or so minutes that we have. Is that right, Trent?
Yeah, we're good. Yeah, some of these, the last few have been around. We've been going on for about an hour and 45, but okay. Whatever the flow of the night ends up being. So it's a shorter night is not a bad thing, but I appreciate it and all the presentation. And so I'd had your bio all ready to go, and we're on now week 7. I screwed up introducing you in your bio again. So one of these times I'll get it right. And then thanks for taking time out from your newborn baby. You just had a baby a couple weeks ago, so that's awesome, baby girl. So thanks for being on here for that. So
happy, healthy 2-week-old baby girl. So
that is awesome.
If eyes look bloodshot, it's because they are, and I'm ridiculously tired.
But you were still here. We appreciate that. So
but I'm still here.
That's awesome. I'm sure there's got to be questions. No one can be this silent the whole time. So
feel free to go off mute or type something in the chat. Questions about anything at all drone related.
Hey Logan, this is Ben Shinaberry. We have been using drone ortho images in our Alta surveys, and we fly a lot of stuff just because we've done it for a while. One tip that I have done on some of our AutoCAD backgrounds is using the fade and transparency controls within AutoCAD, because it makes the image a little more subtle. And then if you have a high contrast area in the high resolution ortho, then sometimes you can't read some of the text in the AutoCAD. And instead of using wipeouts, we just soften the image behind it. And you can do that right in AutoCAD.
Yeah, and that's a good point. And that actually brings up what I often call more of the artistic side of photogrammetry and CAD work. That's a lot more about making it usable, making it legible. Everything from colors and contrast to symbology to transparency settings on the ortho photo. One of the biggest things with ortho photos and CAD that we found is not with smaller projects. It's when you are dealing with hundreds of acres. Project sites, when the ortho photo exceeds about 1 gigabyte, is when we start seeing a lot of projects particularly in Civil 3D, start seeing size issues. And that's when you start having to bring in addition to those transparency and coloration issues, you actually have to start bringing in creative compression algorithms as well. With, once again, the main goal is to optimize that right balance so that it's usable. At the end of the day,
right.
What it is, your goal is to have it usable, to have it be that you glance and you can get the information that you need out of that survey.
Yeah, using the tiled orthos works better in AutoCAD too, instead of just the one giant merged ortho photo. AutoCAD is clunky when it gets past those 1 gigabyte sizes.
And those tiled, the other thing with tiled ortho photos too is that they're still very difficult to transfer. If you have 100 tiled photos and it's a 6 gigabyte zip file or something, transferring from one person's workstation to another is a huge pain. So this is where, again, it's that art side of thing that I think is actually really fun, where you start learning the different tricks that you can use on different projects to make sure that end result is super usable.
Yeah.
In fact, one of the things that we've been working on a fair amount lately is cloud viewing on a lot of this stuff too, so that you can view an entire project, not just the imagery, but the line work on it as well, in a cloud environment, so that you don't have to download anything, even Civil 3D software. In fact, let me see if I have a demo up here at all that I can show. Yeah, I'm going to share my screen here. Just to show, click share. This is just one of our web viewer projects of another, I think this was used for an ALTA survey, but this is all in a web viewer, not actually in AutoCAD or anything. Once again, you can see it's actually got all of your paint striping is interpolated under the cars, clean contours that don't go over the cars. And this is one that's great for sharing with clients because they do not need to have a Civil 3D license. As I'm sure most of you guys can view DWG files, but many of your clients would not be able to. So being able to actually have 3D data in a web viewer that is accessible by clients without software is just another cool thing as part of that, that artistic side of ultimately making the data useful. That's what this is all about. It's about taking all of this survey data and making it way, way, way more useful. Any other questions about drone surveying, or any problems that people want to talk about that they've had or seen?
I have a question. I guess first, do you guys fly any of your own jobs, or do you guys do any flying yourselves?
Only for test purposes. So we do a lot of flying for testing purposes, but ultimately we work all over the country and we're not on the job site.
Well, I guess my question is either to you or generally in the group. It comes off as something that we saw probably 3 or 4 weeks ago. A guy gave an example for CAD drawing, but he also supplemented an aerial image in the background. During his presentation, he was flying in the center of the road. In my opinion, as a remote pilot, I think that's not how it's supposed to be done, but I know a lot of people interpret it operating over people differently. So I wondered what your opinion was.
Yeah, our answer to all of that is be a responsible operator, right? At least us, we're here in California. If you are thinking about flying directly over the 405, that is not a responsible way to operate. If you are in a rural area where there is a single road that sees a few cars every hour or something, it's totally fine to fly over the road. Wherever possible, yeah, we encourage responsibility. If there is a street, set up your flight plan so that it doesn't fly over the center of the road, so that it flies over one side and then the other side of the road, so that you're spending as little time as possible. That's what we generally encourage, because ultimately we've been fortunate enough to have a lot of conversations with the FAA about this stuff. And what they're mostly interested in is bad actors. They're interested in people that are egregious rule breakers. So we say, be safe, be responsible, minimize risk wherever you can. But ultimately, it's different based on, your contracts, different people's level of safety and responsibility. We're very, very big on just kind of safety and responsibility as a culture. That's what we press is almost more important than the law is just be a responsible operator.
Thank you.
Yeah.
Not that many shy people in this group.
This is John Brady. I've got a question for you, Logan.
Sure.
I'm up in Alaska. We've been flying for a while here, since 2016, I want to say. And I started talking with our DOT's program coordinator, and he recommended putting down blue and red targets, since these cameras are RGB sensors. And I thought, oh, that might be an interesting idea. And you being a photogrammetrist, having seen so much of this data, I was just kind of curious of your thoughts on that.
Yeah, absolutely. So the one thing that we certainly agree upon is that the ground control points do not need to be black and white. In fact, in today's day, let me share my screen once more. We actually have manufactured and sell own paper-based biodegradable single-use ground control points that are pink and green. This is our preferred color palette here, but basically using high contrast, easily visible colors really, really, really help the photogrammetrist just see things. These are what we've developed with working with all of our clients. Like I said, for us, these are paper and biodegradable, so that on larger sites, you hammer a nail straight through the center, and you can leave it there, and the elements will turn it to mush within about 6 months or so. So on larger sites, you don't have to go back and pick everything up. You don't have to worry about littering and all of that good stuff. But to the point of colors, this is a great example to show, yeah, you're right. High contrast, high visibility colors are much better than the traditional black and white colors. Because black and white was developed for an era when the photogrammetry was black and white. And I should point out, they are available on our website or on Amazon. You can buy Aerotas ground control points.
That's a great question, John.
I swear that wasn't a plant, by the way, to try and like plug our own product.
Yeah, that was unabashed free advertising, right?
But really just, oh, that was a softball. Thank you.
Yeah, that was a good one. I love it.
I have a question.
Yeah.
Listen.
Cool.
So processing takes human hours, many, many hours. I come from field crews that can bust out 1,000, 1,200 shots in a day.
Yep.
It's not a problem. Robotic total stations. So if you can come in with codes, all the line work's already on your layers and your topo shots are in there and your break lines and 3D polys, you know, I can see you started out in a few numbers earlier at like half acre. Just so many acres was usable as a tool for using just a UAV running around the site, doing some topo or picking up items off of an Alta, parking spaces and things. But I can't justify, and I actually remote pilot. I let my license expire because I couldn't really find a whole lot of uses for it. I don't actually own one, but couldn't really get into it. I can really sell myself onto it. It's very interesting. See some great presentations, but I never see those presentations really delivered to clients for them to do the same thing I can on my computer screen at the office to utilize that product. 3D poly lines and regular lines and coded lines, those all speak to me, and I can give them to somebody else and they can work with them. I'm trying to figure out that relationship of really when these UAV or UASS, the whole system, me and it, really pays off other than spending $150,000 for a LiDAR running up and down road corridors, picking up from back a curb in for a road project. Another gentleman that was on here mentioned using one on an Alta. It'd be hard, you know, I like seeing it from an air on a very, very updated aerial photo related to whatever my coordinate system may be, rotated, translated into it. So I can make sure that I didn't miss a parking space, something like that. But other than that, with the contours and, you know, I'm still like the guys back in the day when they first put their EDM on top of their T2 theodolite and they didn't trust it. So sell me on it.
Yeah, sure. And the short answer is the best way for us to sell you is with the data itself. You can check out some of our demo files online. Like I said, aerotas.com. Grab one of our demo files of what we deliver. That's a way better sales pitch than I actually can sit here doing it. It is topo points. It is 3D polys. It is tin surfaces. It is coded very close to national CAD standards. It should be very usable and familiar data to you.
I do understand it. I mean, to interrupt. Let me also note that my working area is Kentucky. So we have lots of trees and hay fields and things. I know you all have a lot of desert and, you know, there might be some bushes or a few trees in the way. California, I'm assuming, is where you're at or had mentioned prior.
Yeah.
So it's just sites are really hard to find where you're like, yeah, this is where we're going to use it, unless it's like a paved or open dirt area where somebody did some previous grading.
Yeah.
And you can tag.
And that's, I hopefully was pretty straightforward in my presentation too, that this is not a tool for every job. If most of the jobs have dense vegetation, then it's going to be a lot harder for that ROI to make sense for you. At least until the cost of LiDAR comes down significantly, because you are going to have to supplement the drone data with a lot of ground shots where there is denser vegetation. For areas that are more urban, more built up, might make sense for you on those projects. If you do any earthworks or grading projects, it would make a lot of sense there. Oil and gas projects, a lot of times they scrape the land too. But if you are just doing, you know, large lot residential topos or something and half of it's vegetated and tree covered, drone's probably the wrong tool. It's not going to save time.
Now, you had mentioned the LiDAR, you know, getting into the LiDAR, $150,000, but you could take like third, fourth, fifth returns and be somewhat tagging the ground better than pictometry with using a regular camera, correct?
Correct. And that's where LiDAR does shine, is in those vegetated areas where you do take last return shots. And it does create a much more reliable topo surface in vegetated areas. And that's where that, like I said, that LiDAR thing that DJI is coming out with, it's called the L1 payload. It's coming out early next year, is extremely promising because it drops that price to something where the ROI starts making sense. And that's where it would make a lot more sense for someone like you that does work in a lot of vegetation. Because yeah, like if you're a surveyor in Nevada and there isn't a tree for 100 miles, you'd be crazy to not use a drone. But yeah, in Kentucky, you've got a lot of vegetation, and it's that really means that no, I can't necessarily sell you on it, because if that's the type of project you do, the math's a lot harder.
Okay, I just wanted to see if there was something I was missing out there.
No, and LiDAR is, that's why so many people are holding out hope for LiDAR and for getting that cost down, because that is the answer. We're just waiting on the right hardware to actually be good enough.
Okay. Thank you.
Logan, Rob
Kenny, I
McMillan.
would say that you can collect a lot of data in the office off the drone flights and then supplement where you need them. Instead of taking 1,200 shots a day, you could take 400 of the tough shots out in the field, and then off of the drone flights, you might draft 2,500 in that same day. So
Right.
the speed at clicking those points in the office and the option that it gives you to do it in the comfort of your air conditioning and do twice as many, but you still have to take the 400 difficult shots or take shots on the critical elements that you don't want to trust the precision level of the drone work. So
Right.
if you're doing, inverts and need an accurate measurement on a storm or sanitary manhole, you want to take that shot, not trust the drone flight for it, but the contextual data around it you can gather from the drone flight and supplement the 3D file with it. And in the office, I've told our guys it is virtually surveying the same points that you would take in the field. You're just taking it off of the point cloud generated from the 3D outputs.
Okay.
And I'd jump in with this one also. Did you ever do a project, say for an engineering firm or for an engineer in your firm, and you go out and you do all this work, and you might have a 2 or 3 hour drive to get to that location, and then you do all this work and deliver it, and about 2 weeks later they call you up and they say, hey, did you get the wellhead on the property next door? Because I really need that. Well, if you needed it that much, don't you think you should have put that in the request when you identified the things that you needed? So you might be able to pick that off and get it close enough to plot on a 40 scale topo map, right?
So the initial data collection and big picture, even more than what you even planned on going to get, can actually be gathered. So it does make sense for sure.
And
we do have a
on, sorry, Logan, go ahead.
Yeah, I was just going to say, we do have a handful of clients that do just that. They fly every single site and they rarely process them. I obviously do my best to encourage them to process more data, but they do the vast majority of stuff that they shoot in the field, and they do a lot of pre-construction work. So sometimes when the asphalt's gone over and they've covered up this valve and someone forgot to shoot it in the field, then they'll go through the drone and process it so that they have this perfect record of everything. So whether it's just total CYA to prevent missing a shot in the field, or whether it's fly a larger site so that you can get that thing next door, or even anticipate if the neighbor's going to come back and say, hey, I want a survey, or hey, I was thinking about doing a survey on that adjacent site, and now I want to. But people go out in the field, they fly 4 times as much of an area just in case. So there are lots of people that use it for that use case as well. And
I want to jump in and say, Ken, I'm glad that you're looking at this and saying, I'm not sure if this is the right tool, right? And because that's a critical decision that we all have to make as we go out there and do this work. What is the right tool? If you're in an area where your tree cover is deciduous, maybe this is something you don't deal with from, mid-March through October, but maybe when the leaf off is it gives you a better view of the ground, maybe then that's a time that you could incorporate it. It could also be letting your clients see what your data product is from that, or see what the orthophoto mosaic is from that, and say, oh, and by the way, we've got this additional product that we can make available to you for a mere sum of X dollars, and throw a little bit of extra money into the company coffers, right?
Right. So you're talking about the ortho photos themselves stitched together.
Right. And
Okay.
a number of years ago, we had a presentation from a firm at my local professional society chapter, California Land Surveyors Association, free plug, by some guys that did some really amazing 3D laser scanning. And they were really into oil and gas and doing some really wild stuff. Like the backside, the inside of Disneyland. So they did some wild stuff. It was fun to see the stuff they were doing. But one of the things they brought to show was, this was right at the beginning of 3D printing. And they brought in a 3D printed deal from an oil field that was about the size of a Monster can. And it was some kind of a pressure vessel that, had pipes coming in at one side and pipes coming out near the top and something else coming in and little valves on the side and whatever. And one of the people in the room said, well, why would you ever do this? Why would you print something like this? Because it's totally meaningless to all of us sitting in the room, except for the surveyor that did the work. And he said, oh, this? Because the client wanted me to, and they paid me $1,000 for this. So therefore, it was just something else to sell the client. And if it was something that the client wanted, and what they had actually done was, it was really something bizarre. Like they had scanned this vessel and they had to replace something inside. And they had an access hatch and they had to shut down a refinery, drain this part of the system, open the access hatch, and then really the piece that he brought to show us was just the one little pressure vessel. But they had to be able to bring this other piece in and do kind of a Jenga move with getting this replacement thing that goes inside the pressure vessel into place and plan the whole move. So they used all this 3D printed stuff to plan their moves. And, think, well, okay, whatever, that's got to be costly. No, an oil refinery is something like, I don't know, $100,000 per, $1 million per hour or something for the time that it's shut down. So $1,000 on a 3D printed thing was nothing. The cost of the surveying was nothing compared to how quickly can we get this taken down and put back up again. So you don't recognize the potential for some of these things until you get somebody who's willing to break out their wallet and throw down a big chunk of change for that. And a lot of times, if you're doing some kind of land development, maybe that's exactly what the developer wants to see, or maybe not even pictures of his property, but pictures of the lake out that mountainside property has a view on from that property at various locations, right? So it could be all kinds of weird stuff that you can pull out and use as part of the tools. So anyway, that's it for me.
Kenny, I was going to say, we kind of started where you were, and we would just use it as almost an ortho background and just almost QA/QC the field guys. And that's kind of the way we started it. And then it was start tracing the parking stripes, right? And so you had hundreds of less shots because you're tracing parking stripes, and because you don't need those accurate. But if you topoed down the center of the drive aisles, you still use it as part of the surface, but you don't, so we started with baby steps, and would slowly, gradually kind of just get into more things as we
Right.
trucked along, but it was baby steps and learning as we went and always checking the data, right? I mean, that's our survey mentality, is always checking. But I would say just start back with going back with the ortho image to start with, and have that nice QA QC on the field guys. It's also a nice background, to deliver to the client and stuff like that. But start with baby steps, and you might kind of get yourself back to where it does. Because again, it's, like he says, 20, 30 minutes on the ground, maybe an hour by the time you do drone flight and shoot your ground control and that kind of stuff. And then it is a lifesaver.
Totally agree.
So,
start small, and like I said, you
Yeah.
you do not start with the $150,000 LiDAR.
right.
Even if you have the budget, don't do it.
And even all of our stuff is just the Phantom 4 Pros. I mean, we're not even running the RTK systems yet either.
Yeah.
So it's we're getting all the good results that we want out of it. And so I love it. It's been working good, and just the QA QC on the field guys is probably the best byproduct of the whole thing.
Right.
Yeah, with the oil and gas, we do predominantly I think we have about 80 crews just doing pipeline or power line work. And we've gotten the majority of our clients to pay us for the drone work now, because we went with a web-based viewer that per client, per project, per PM, we can grant them access, and they can look at all the survey data, the drone flights, all of our laser scanning, everything, without having to download any software. And we've gotten to where they're even paying us maintenance fees now to pay for the software we've developed for them, that we were just going to do just to do, because it's a lot of data to manage, and it's worked really well. We're starting to we're kind of the same boat. We're nationwide, so there's 10 of us to do drone work, 3 of us to do scanning, and then so the 160,000 miles is because I cover East Coast to Texas, north to North Dakota. So I have 2/3 of the country is my area. So any given day, I don't know what state I'm in, which is mind numbing to go, okay, international feed, survey feed, different coordinate systems. Do we use UTM because it's easier? What do we want to do? So it's a lot of chaos, but we're starting to do a lot more with the LD work, new subdivisions, where they get their clearing done. We can go out and fly it. We can lay all the lots and everything down to where the developers can go, oh, if we make it a little bit smaller, we can get 20 more lots, or we can do this, or, well, there's no way in hell this is going to work, type of thing. And it's really started becoming a good revenue source. Just ideally, we were doing it just to field check the crews, because we cover so much country. It's nice to know that, oh shit, they didn't shoot those 2 light poles. Let's pop them in off the photography real quick.
Yep.
Or we drive 12 hours.
Yeah, no, exactly. That's where the lifesaver is on that end. So
yeah,
that's cool. Anybody else got anything before we let Logan back to his baby?
I've got.
Go for it.
Sorry.
Go for it.
Go ahead, Pete. I've got a question, a couple of questions about like business, your business processes. The first one being, you're obviously getting a lot of data from other users, and your company's focusing on processing that data and sending it back to them. Do you structure your business, is your business structured in that you get to resell those products to other people? Do you resell the ortho photos as part of your standard practices, or is it a individual basis?
I can answer that easily. Absolutely unambiguously not. You own the data. It is your data. We do not and cannot resell it or give it to anyone else without your authorization or your specific direction. This data is produced entirely for you. Our goal is not to try and like aggregate and create some database of stuff that we can resell. You own the data, 100%.
Okay, cool. And then, so my other question kind of still plays off to that. I've been having to deal a lot with regulations recently, and I also am from Alaska. I know John, he's a friend of mine. You know, there's a lot of stuff with boards going around, either half of the boards are kind of distinguishing between photogrammetry and surveying, and the other half, like for the state of Alaska, definitely our board is basically just like, if you're making a map, you have to be a land surveyor. And, you know, are surveyors your primary clientele? And I was just kind of wondering if you ever run into any trouble with any boards or anything because of the third party aspects. You know, I know your service would obviously be great for scientists who don't typically hire surveyors, who some surveyors think they should be hiring them, you know, some boards especially. I'm thinking of boards in particular.
No, you're absolutely right. And the short answer is we work exclusively with land surveyors and civil engineers for that reason. There are lots of people that want us to come and do it. And like, it's the work that we do is very unambiguous. If there is not a licensed surveyor working on the project, like it would qualify as land surveying and operating without a license. I'll give another shout out to Rob and the CLSA. We've been working with the CLSA, the California Land Surveyors Association, forever. We've worked with the board in California as well to make sure that we do carry a very responsible relationship with all of the varying regulators to make sure that what we do is legal. To the best of my knowledge, what we do is legal in 49 states and all U.S. territories, with the exception of North Carolina, which is particularly weird and annoying and obnoxious.
Yes.
But other than North Carolina, whose board does have some very, let's call it frustrating rules that I do not agree with, that we do operate nationally. But as part of that, it's because we work with land surveyors. We will not work with someone that is not a surveyor. Because, I mean, heck, you guys are surveyors. You know the legal implications of doing this stuff without a license. It gets bad once someone spends X million dollars on a project site only to find out that the idiot on the ground didn't know how to shoot control.
Good stuff.
Hey, Logan.
Yeah.
It's Jeremy Ketty. I'm a geomatics student up out of Seattle, Washington. So pretty early in my journey, wanted to just kind of hear from you. What should I be paying attention to in your area of expertise? What are the opportunities that are out there, the economic opportunities that are out there? And, you know, where do you see the most growth? And what's just noise? Maybe something along those lines.
Great question. There is the data processing side is where there is the most growth and the biggest economic opportunity, without question. There is a need out there for high quality photogrammetrists, people that are high experienced CAD techs that can manage this sort of data, process this sort of data, and are familiar with working in big data, like dealing with hundreds of gigabytes of files. There is opportunity and there are economic opportunities there. The noise, I would say, is the desire to make a full-time career out of being an independent pilot, what we call drone service providers. The problem is there is just a ton of competition. Everyone wants to have a job of being a drone pilot. And they'll go out and they'll try and say, I'll fly this site for you for, you know, $50. And there are a lot of them. There are a few companies that have been successful with that, but that is a really, really, really challenging road to go down. If you're thinking about this, the independent drone service provider is a very challenging road from our experience. People that are successful with drone programs, they use their drones as part of their other job. Like I said, with surveyors that have the drone in the truck, not I started a company where I am flying a drone all day. That's where a lot of the noise is, even though that's where, you know, many of the varying posts and Instagram things will be of people that like to fly their drone. But the opportunity side is very much on the data side of things, not the flight side of things. These aircraft, I've said it before, I'll say it again, they fly themselves. They're stupid easy to fly. It's really, really, really easy. There are some potential exceptions if you go down some really, really specific rabbit holes, but generally speaking, the data side's where you want to be.
Thank you.
Great answers, Logan. That was good. Anybody else? Sean, you're quiet today. Wait, go for it, Sean. We got you.
Okay. So my experience with doing some processing work with some of the, actually this question would be for Logan. I've processed some work that's come back from photogrammetrists. I'm out here on the East Coast, and we've seen a really poor product coming from some of their mapping. Could you speak a little bit to that and how that occurs?
Yeah, poor. First, I would ask poor in what sense?
Poor in the sense that the accuracy that we should be getting, we're not getting. And these are large scale corridor projects. So
yeah, and that'll go, so the accuracy itself is primarily determined on the photogrammetry side. And that's where a lot of, quote unquote photogrammetrists are not going to be actually licensed photogrammetrists in any way. They'll just do something in drone deploy. And like I said, drone deploy is very fast, very cheap, very good at getting a quick picture. But especially on vertical accuracies, you would be feet off, even if you do incorporate some ground control points, because there are just numerous other things out there. So the accuracy of a project is determined in the photogrammetry step. You remember those steps: photogrammetry, CAD drafting, or Linework drafting, CAD finishing. That first one in photogrammetry, that is what determines your accuracy. And that is where a quality photogrammetrist needs to be involved, because anybody can drag and drop photos to a web processor, but it takes a skilled eye to be able to say, even when it passes through the software, no problem, to be able to say, hey, I think your ground control point distribution is bad and that there's going to be errors in this corner. Expect errors of up to a foot, or go out, shoot some D points, shoot some corners of concrete or something, and we'll tie those in to tighten. So having a skilled photogrammetrist in the loop, a human in the loop, that's one of our kind of principles. Everything we do, we're not a black box software company. We are, in fact, very open about what we do because we know it's hard. And we have humans in the loop that review the photogrammetry stage. They review your control points, they review check shots, they review camera calibration parameters and matching, and insert 100 other things on our data processing list to ensure that you get the highest quality accuracy, or in a worst case scenario, if you didn't, that you're at least aware that something might be off by half a foot.
Okay.
Yeah, it's another unfortunate side effect of this industry. It's becoming less of a problem, but I'd say about probably 3 years ago, there were so many of those independent drone service operators that I was talking about that seems to be photogrammetrists and surveyors. They're like, oh, I'll get you a map, no problem. They do it. They don't know the first thing about what datum they're using, and they come back and it's off by 100 feet. And it's like, what the heck? You clearly know nothing what you're doing. Right. So many of those have died out, thankfully, which is a good thing. There are still a few of them around that aren't actually particularly good at what they do.
Hey, Logan, one thing with those corridor collections, a lot of times people will put GCP targets down the center of the road, and then the photogrammetry doesn't have anything to stabilize the wings, the lateral extents of that. So you'll get torque within those corridor sites that will flip the verticals on either side. So that is an issue in corridor work.
Yeah, that is absolutely 100% correct. If you give me 30 seconds, I can actually pull up. We did a case study specifically on corridor mapping. So just give me one.
I did notice in one of your slides you had shown your pairs of GCPs. That was nice to see.
Yeah, but we did a much more intensive example of it. Here we go. Share my screen again. This one. So here is corridor GCP placement. We did a project where it was a pretty much straight as an arrow corridor. I believe this one was about 5 miles long, and we set pairs of control every 100 feet and processed it probably 100 times with using different ones as GCPs, straight down the middle, or what we would call, like you said, linear on the right, zigzag, and then setting them in pairs. And also we were testing distances. at what distance do you start seeing errors? Errors to us is anything more than a 1/10 of a foot vertical on independent checkpoints. And what our research found is that actually we were kind of surprised. The pairs do not dramatically increase accuracy over zigzag. It was within the margin of error statistically. But you are correct. Linear ground control is a bad idea on projects. You need to do either pairs or zigzag and never exceed more than 1,000 feet between control points. That's for non-RTK projects. If you have RTK, you can go a little bit further. But for non-RTK, never exceed 1,000 feet between control points. And you do want to do a zigzag, and especially at the ends of the corridor, have pairs to keep any twisting from happening along that center line of GCPs. So great point, and it's another thing that we've done a very extensive case study on.
Awesome. All right. Anybody else?
Do you guys do any LiDAR processing, like fixed wing, Logan?
Yes, sir. We do LiDAR processing. Like I said, for us, the reason it's not a huge component of our business is because it's so darn expensive right now.
Yep.
We do.
I think last year I flew 3,000 miles fixed wing pipelines.
Yeah.
Doing geohazard analysis, slope shades, hill shades, and everything. And I'm doing 5 more states next year. So I might be reaching out to you then.
Please do.
It's the horsepower processing. It's each state last year generated about 3 terabytes of data.
Yeah.
For deliverables, and it starts to get very painful. I'll put it that way.
I totally understand. But yes, we are used to doing project sites that are even on photogrammetry that are measured in the hundreds of thousands of photos. Yep. So yep. Big data is a language that we speak. Doesn't make it easy.
But it's easier for me if you do it, so that's good.
A note on LiDAR processing, when we talk about our processing workflow that goes from that, photogrammetry, then CAD drafting or Linework drafting and CAD finishing, we already use hybrid workflows where we extract some data from a point cloud, some data from an ortho photo, some data from a DSM, and then combine it all. So even in photogrammetry, we actually are using point cloud data for certain steps. So when it's LiDAR data, it's just like, oh, I guess that's all you have. We certainly encourage people that fly LiDAR to fly LiDAR plus imagery because that gives a lot of context.
And that's what we do. Yeah.
And that way you can use that hybrid workflow to get the best of both worlds. So that hybrid workflow is the way to do it with LiDAR.
Yep. If I'm already paying for the airplane and the LiDAR, I might as well pay for the photography too.
Yeah.
Because it's really cheap, but it's hard to get the second time. But yeah, we did
I'm sure it's cheap only compared to the amount that you're spending on the LiDAR.
I've lucked out, but we had Pennsylvania, New York, right when COVID hit, and we had to do it with no snow on the ground. And it was very entertaining to try to figure out how to do mobilizations from a separate state to fly New York, to land in a separate state, to refuel because of quarantines, and New York just flat not wanting to let people in the state.
Yeah.
It was very painfully entertaining. I'll put it that way.
That's where I'm lucky to be able to sit here with my office surrounded by computers and work remotely.
Exactly. Yep. Wade, did you have something? You gonna jump on, Wade? There you go. Nope, you're muted. No. Got nothing. Nothing.
Logan.
There you go.
Now we can hear you, Wade.
All right, cool. Awesome. Sorry, the bows weren't working out. Sorry if there's a little bit of jet noise. I'm up at Nellis Air Force Base. I'm a Master Sergeant. I've been in the Air Force 15 years. I am a surveyor by trade with the military, a 3E5. So we're called an engineering assistant. I've got a hummingbird trying to get after my MSR. I'm camping right now at FAM camp. But yeah, I do AutoCAD, I do GIS, I do land surveying. How effective could PIC's 4D be with taking maybe an Icon or any kind of camera up into maybe HH60 or Blackhawk and taking pictures of the ground and tying that to some ground control points?
Very effective. What you're do is effectively just manned aerial photogrammetry. Same exact principles apply. In fact, the same principles that I've talked about from photogrammetry perspectives apply whether it's a drone at 50 feet, a plane at 5,000 feet, or a satellite at 50 miles or 500 miles. So yes, we have seen numerous things of people actually taking a high quality camera up into a helicopter, snapping photos, oftentimes even manually. The hardest thing is simply getting the overlap right, because the drone or the helicopter will not be controlled by an autopilot software anywhere near as precisely as a drone autopilot that snaps those photos within a foot of where you want it to get perfect overlap. So making sure that those flight lines are the proper width apart, that's the real trick to doing something like that. That said, if you nail that out, the processing side, yep, totally doable.
And this is Rob McMillan. Wade, on the bright side, I'm guessing you're not paying for that helicopter out of your pocket. So if you got to go up and fly it again, you got to go up and fly it again, right?
Yeah, we'll get some overlap no matter what. It might take 2 or 3 times. Who knows?
And the Pix4D is not, as I understand it, it doesn't work exactly the way photogrammetry software does. It works from a process called structure from motion. And so more photos, more overlap seems to be the best way of going on that. Give me a thumbs up on that one, Logan, or am I talking out of my hat?
Nope, you're correct. The process of structure from motion, it's still strictly speaking is photogrammetry. It is a different technological photogrammetric workflow than your traditional like stereo plotters. Structure from motion is a different technological process, but it's different. It's designed to leverage the use of much more powerful computing, where instead of 2 photos in stereo with a Kelch plotter or something, it is then using a bundle block adjustment of thousands of photos where any single point might be created from anywhere from 2 to 20 matches on 20 separate photos to create a single point. And then you do it 100 million times because a computer can do that, which obviously a Kelch plotter wouldn't be able to. So you are correct. A lot of that is I leave the discussion of which terms to the academics, and I focus on the process, but you are definitely correct that that there is debate of whether or not Pix4D is true photogrammetry.
And Wade, I think you said you're at Nellis?
Yes, sir.
Which, if my memory serves, is just on the north side of Las Vegas. So you better make sure that Trent has your contact information so he can start recruiting you ahead of time.
Absolutely. I got 5 more years left, and I'm actually fixing a PCS to North Carolina. I guess everybody's happy with the boards out there, but I'll try to fight it just to see if I can't maybe become one of the PLSs out there. I've already talked to a bunch of survey guys out there, and they're all retiring, so there's nobody to come up underneath the wing.
That's it. Well, spread the word around about our professional societies with your colleagues in arms there, and let them know that there's something waiting for them on the outside. It's just a continuation of what you've been doing on the inside.
And Rob,
yeah, absolutely.
Wade's already he's already interned with us on his days off.
Right on.
Yeah, Trent opened my eyes to what a surveyor should be doing. Based on we're multi-trade, so we're GIS trained. We're ArcGIS or AutoCAD, Civil 3D. I can do that. Map 3D using attribute tables and AutoCAD. We can do all that. Plus, I'm ACI certified, so I can test concrete. I can lay concrete. I can set string lines. It's just we're so developed to be masters of all, or not masters of all, but jack of all trades, masters of none. So luckily Trent took me underneath his wing and taught me what I should be doing as a surveyor. And I learned a lot from him. And I hopefully, as I put on more rank and move into a more structured leadership position to where I can influence our career field, kind of teach the basics and go back to our original name, which was site development, and really teach the guys that, you know, we don't have to stake a point. We don't have to go back to AutoCAD and do a 5-foot offset, upload that point to the controller, go back out to the field, and then stake a 5-foot offset. So it was a great learning opportunity, and I appreciate it, Trent. But going up into an HA60 will be absolutely amazing, and hopefully I'll be able to take some photos of stockpiles and maybe some landfills and get some preliminary data. That way, when it gets filled, we can do see what the fill analysis on it is. But Logan, I appreciate your answer. Thank you.
No problem. Happy to help.
The other thing, Wade, you might do, Pix4D will run a video and extract frames out from a video. Sometimes you do get shutter motion in that, but you can just hold down a video and run a video around and it will extract the frames.
Oh, wow, that's absolutely amazing. It makes probably things a lot easier.
I'll actually put out, yes, that is possible. It comes at the expense of accuracy. The even super high quality, you need like, you need $100,000 video camera to match what a basic point and shoot can do in terms of one-for-one accuracy. So it is possible, but I would say we discourage it where possible. Good photos are much better than video. A bit of extra mission planning up front to get your photos better will be a lot better at the end than just trying to collect video and say, yeah, I hope it works. That's my opinion. It's certainly possible, but from the surveyor's perspective, where 1/10 of a foot matters, we don't love it.
Oh, thanks, Logan.
All right, I think we'll let Logan get back to his family. That was a lot of Q&A.
Family and some sleep. I certainly could use it right now.
That's awesome. So cool. We appreciate everything, Logan.
Of course. Yeah. Thanks for having me. I'll get that slide deck together to you, Trent, and we can get it out to everyone.
Yeah, and I'll send it out to everybody. So that's awesome.
Thank you. Congratulations.
Yeah.
Thank you, Go. Appreciate it.
Thanks, Trent.
Okay. Yep. Of course.
Thanks, guys.
Bye, guys.
Bye.